In this portion, we're going to learn first how to graph a function where it's not quite so easy from a table. So the table given in example 2, and I'll try to write it really quickly, shows SAT scores on a math section from 1997 to 2003. Now, when they do 1997 to 2003, right, and what they're gonna do is they're not gonna write on the x-axis 1997, 98, 99, because it's really hard to represent that as an equation. So what they do is they make 1997 equals year 0. And then 1998 equals year 1. And 1999, year 2, etc. Right? So that's important, which means that 2003 is really going to end up being year 6. And so first we're going to start with our table, which is going to be years since 1997. And that's going to be year 0, 1, 2, 3, 4, 5, 6, meaning year 0 is 1997. You always have to remember that. And during those years, we're going to have the average math score. So the average math score in 1997, which we're calling year 0, is 511. The next year it was 512. Then it was 511 again, 514, 514, 516, 519. It looks like it's going a really slow rise over time, right? So, I mean, I drew this helps us identify our ordered pairs just a little bit better, right? So the ordered pairs look like they're, right, 0, 5, 11, 1, 5, 12, etc. And that's what we have to graph. What do we do with that? Because you can notice, like, this is going 511 to 519, and this is 0 through 6, right? So this bottom part is easy, right, if I'm graphing. We did that, oh, sorry, it's a little bit tilted, but 0, 1, 2, 3, 4, 5, 6. And this is years since 1997. In other words, year 0, 1997, 98, 99. Sometimes I actually write them underneath. That way it's easy for me to see. But what do I do on this axis? Like if I do 100, 200, 300, 400, 500, I'm hardly going to be able to see anything, right? As I'm trying to plot these numbers up here, it'll look like they're like a straight line across. How do I plot that there's actually something happening here? So I have to choose a scale. So my first step is choose a scale. Okay, so this lets me put my points on the graph that's a reasonable size. Okay, so since these, and these are they're calling these S values, go from 511 to 519, I'm going to put like a little this that shows there's a break in the graph, or there's a lot of numbers, and I'm going to start at 510. And I need to get to 520, right? 510, 14, 16, 18, 20. I should have made it just a little higher. So I'm going to put 520 and 514. Oops. 520. Actually, 522. Seemingly, I can't count today. I'm going by 4s. 4, 8, right? Okay. So here now, when I plot things, I can represent things just a bit better. So year 0, 1997, here's my score. See, in between is going to be 512, so 511 is going to be right there. Year 1, which is 1998, 512, right here in the middle. Year 2, whoops, goes back to 511. Year 3, 514, I'm right here. Year 4, also 514. Year 5, 516, right here. And year 6, 519, so right here. And I've plotted, and I can show that relationship on this graph because I did this scale very carefully so it actually shows the differences. Okay, let me move on to the next thing, which is example 3. Now, this one, we're going to start with a graph that's been given to us in the book, and we're going to do a rule for the function. Okay? Here, we're going to start with the graph. So this is the before we drew the graph. Now we're starting with the graph. So x, y, and let's see, my x values go up to 6. 0, 1, 2, 3, 4, 5, 6. And my y values also 1, 2, 3, 4, 5, 6. Okay, and I can see that we're, and again, the book told us where these dots are. I'm just copying right out of the book. I'm not doing anything else. They look like that. Okay, so now I have my graph, and my instructions are write a rule for the function. So my instructions are write a rule for the function represented by the graph. And then identify domain and range. So I'm asked to do two things. Identify the domain and range of the function. Okay. So what is my rule? Well, to do my rule, I'm going to first do a table. So here's my table. And actually, I shouldn't have started with 0 because there's nothing on 0, so I'll just kind of skip that. So 1, when x is 1, y is 2. When x is 2, y is 3. X is 3, y is 4. X is 4, y is 5. X is 5, y is 6. Oh, and I guess I should just leave this one blank as well. Okay, so now I have my table. Can I see a relationship between the inputs, right? Remember, this is the input and the output. Do I see a relationship between the input and the output? Yes, I can, because I can see that the output 2, the output y, is always 1 more than the input. Right, here's my input x, and y is always 1 more than x, right? So that is my rule. So once I've got my table, I write my rule. So I've got this part. But the third thing they're asking me, I'll do that one in purple. Identify the domain and the range. Well, my domain is my input, my x's, right? So my domain, which is x, which is inputs, is 0, 1, 2, 3, 4, 5. 0, sorry, I should not even start. 1, 2, 3, 4, 5. Okay. What's my range or my output? Two, 3, 4, 5, 6. Okay. And so I've now written my function rule for the graph. and given my domain and my range. Okay, a couple more things and we're going to be all set with this lesson. So before we go on, actually, I'm going to assign you just to do one more guided practice before we go on to the next thing. I want you to do guided practice number 4, which is exactly like the exercise we just did. Okay, we just did exercise 3, and in guided practice 4, you're going to write a rule for the function and identify the domain and range. Once you've done that, so stop and do that, we're going to do one more thing, and that's my example 4 here. And this is just analyzing a graph. So again, let's see. I need to draw a good graph, so I'm actually going to switch things up and put some graph paper on here and just rewrite example 4 so it's clear for you. And I'm going to do something very similar to what we did earlier. We're going to start with a graph, x, y. In this case, x is years since 1999. Right, so year 0 again is 1999. So if there's 0 years since 1999, it's this year, right? So, and we're going to go up to 6. So 1, 2, 3, 4, 5, 6. And we're talking about guitar sales, right? So on this axis, I'm going to have guitar sales, and we're told it's in millions of dollars, which is usually a big M with a dollar sign. That's in millions of dollars. Okay, and we have 0.4 million, which is basically 400,000. 0.8 million, which is 800,000. And $1.2 million up here. And the points on the graph are that it was 400,000 in 1999, year 0. And the next point is right here. And here. And here. And here. So that's what the graph looks like. And we're told, first of all, identify the independent variable and a dependent variable. In other words, which one depends on which? So we just say, does the guitar sales depend on the year, or the year depends on the guitar sales? Well, obviously, right, the guitar sales depends on the year. So this is the dependent variable. How much you've sold depends on what year it is. And this one is the independent variable. Okay. Then we're asked, describe how sales changed over the period and how you would expect sales in 2006. In other words, as time goes on, to compare to 2005. So in other words, the next year, what's going to happen? Okay. So the graph, what does the graph show when we analyze it? What does it say about the sales? Well, clearly, the guitar sales are going up since the start, since 1999, right? And this 1999 through 2005, they were increasing. And if the trend were to continue, so this is 99, 2000, 2001, 2002, 2003, 2004, 2005, what would things look like most likely in 2006? Well, it looks like, we're guessing, it's probably going to increase. If we had to guess what the sales are going to be in 2006, we're talking about probably it's going to be 1.4, 1.5 million based on current trends, right? So that is how you analyze a graph. You're using the information in this graph to tell you something about something real. And of course, companies do this all the time. All right, I'm going to stop there, and that's the end of 1.7. The next lesson is going to be a review.